Hey folks, welcome to week 9. So today we're just going to look at some specifics in JavaScript around strings, objects, and a technique called coercion. We're also going to look at some arrays, some objects, and objects of arrays, and also how to start including JavaScript files in your browser with the script tag. So a little bit to get through there, so we'll jump straight in. So this particular section, we're going to look at some strings very quickly, null, undefined, conditionals, coercion, and converting strings into numbers. So one thing you typically look at first when you're starting to look at a new language would be, how do you work with strings? How do you concatenate strings together? And, how do you put variables into strings and things like that? It teaches you a lot about a language to figure out how the strings side of what works. So if we're going to look at string concatenation and template literals in JavaScript, the first one is a simple concatenation where we have a first name, a last name, and we focus on the second example here first, I guess, where we're using the plus signs to do concatenation here. So this might be familiar to you, something like Java. The later versions of Java, when I say later, they're probably pretty old at this point, have the ability to do string concatenation in different ways. But this is how I would have learned back years ago how to do it in Java. And up until a few years ago as well, this was kind of the only way to do it in JavaScript until the introduction of template literals that you see here. So let's just do some concatenation first. So if I was to just follow the example, first name equals, let me zoom in there for a sec, John. Last name equals Doe. So now if I just do first name, you can see I have first name there. I also have last name. And that's in the scope of my console now. I have that to do with whatever I want to do with it, right? So if I wanted to put those together, I could do a console.log of first name plus, we want to put a space in there and do another plus, last name. Cool. If we did it without the, we could do without the space in the middle, you'd kind of end up with this. So that's why, we put the space in the middle. And that's string concatenation. That's concatenating two strings together. Technically, I guess in our example here, we're doing 3 strings. So we have a variable, a string that we're just declaring in place, and another variable. So we've 3 different strings here concatenated by 2 plus signs. One of the more modern ways of doing this is to use what's called template literals, where we can do a console.log. We want to do our backticks. And on my keyboard, these are down next to the Z. I have no idea what keyboard layout I'm running. It's just what I'm used to. So I'm not even going to attempt to say where they are in your keyboard, but they're called backticks, and you should be able to find them easy enough. So if I print that, there we go. So what we've done here is we've used backticks to create a string, and we've used our dollar signs and our curly braces to kind of, inject our variables into that string. So that's kind of nice. I think in JavaScript, I always get confused by the amount of languages I need to know these days, but I think in JavaScript we can drop the curly braces, maybe? Doesn't look like it. Let's see. No. Okay. So you can do that in a lot of different languages. You can drop the curly braces once you're doing something very simple, but JavaScript, not so much. When you're learning so many different languages, they kind of munge into one in your head. It's good fun. Um, so one thing that template literals allow you to do as well is a multi-line string. So, we could do something like story equals, and we open up a backtick and we'll say, once upon time, and I'll press Shift Enter to get a new line here in the console, but just in your IDE, you just press Enter. There was a legend named Rory who played a mean guitar. All right. So there's our story there. And if we do a console.log story, you can see it's down on 3 different lines. So we could also do something like this. And we can pull up our story again. And we just put turn there. And we'll do our console.log. So what we've done is that we've grabbed our variable and used it in a template literal here. And you can see how it renders there. And so yeah, so that's a whirlwind trip into how you kind of put strings together, variables together, strings, concatenate them, interpolate them into template literals, and things like that. So yeah, there's some examples over here as well to just take a look at, which might confuse you a bit, but it's good to get confused at this point because you're in a safe space. So the documentation for template literals is really good. So feel free to jump onto MDN. I would encourage you do that and take a look there and get quite comfortable with what we're doing here. And yeah, I mean, it will give you, the correct language around all this as well, which can get quite confusing. So the more you see it, the better. I'm pretty sure I used the correct here. So we're going to venture into the area of undefined in JavaScript, and basically any variable that is created in JavaScript that is not assigned a value has a value of undefined. So you can just type undefined here, and it is a thing. You can do and you can do, yeah, because it's a constant, I need to initialize it. So we can do let, and you can see another life is equal to life. And if we do type of life, it's undefined. So we have, a number of variables there that are just have the value of undefined. And if you try and do anything with those, weird things can happen. And console.log undefined +2, that kind of thing. So one thing actually to note in the examples over here is that we can't do this because this is a constant. So that should be let. And, this should also be let, I guess, and so should this. But we can see, undefined is a value given to something in JavaScript that has no value, which might sound a bit weird. Um, but you will see that popping up a lot in errors, and that's kind of what it means. Typically, you try and do something that is undefined. So you usually do something like, and you get cannot read properties of undefined. And it gives you, a little bit of a hint, which is nice. It says, oh, we're trying to read length on that. Um, so yeah, happy days. Um, so I guess there's undefined in JavaScript, but there's also null, and they're not the same thing. Um, so it can be quite confusing for people even working, with different languages. But the distinction should be, um, is that I'm intentionally saying, um, do do do, uh, number equal null, and then somewhere along in my code I give that a value. Now I I kind of really don't like that style of programming where you assign null to something. I think it just causes problems. It just causes bugs. It just makes code unreadable. But I guess the distinction to make, is when you're first learning the language, is that um, null. You're saying I'm intentionally setting this to null, and I always say if you're doing that, there's usually a code stink there somewhere, which is a technical term for there's probably a better way to do it. Sometimes you need it maybe if you're doing a lot of iterating over loops and assigning variables and stuff, but even at that, I'm like, maybe. Um, because I'd be more used to assigning something to maybe, a default value, um, that kind of thing. But anyway, um, so if we have a variable and we want to figure out its type, we can use the typeof keyword. And it's not a function. I don't think we can run typeof, can we? No. So it's not a function. It's kind of a kind of inbuilt mechanism. I guess it probably does run as a function under the hood, under the keyword and stuff. So it's a little strange. You might expect to do something like this, which you can do, but you can also drop the brackets off it and just do that and type of string, and it returns a string as the type as well. So typically what you see is, if type of life is equal to string, you might do something. Again, I think type checking in code like this is again a sign of poorly written and designed code. Um, because yeah, I've worked in static and dynamically typed languages. I've worked in all of them, but I'm like, I don't see typically a reason for you to have to check types in code. Again, the it's usually a sign that something can be done better. But it's important to understand that typeof exists. Sometimes you have to do it. So don't let me make you feel too bad if you do have to do it. But as we can see on the example here, we can do a type of string, 5, false, type of undefined, and type of null. And this is kind of where you start seeing JavaScript becoming a bit crazy, where you're like type of null is equal to object. So you can imagine, if you're writing an if statement, if person is equal to null, is equal to object, you might want to do something with that person then. Um, but it could be null. So you kind of want to be null checking there. But again, that's a sign that your code is probably poorly written. But anyway, cool. Um, So that's type of. One very interesting one, which I think we covered in the last class, was type of an array is actually an object. And we'll see that a bit more later. But in place of that, you can use array.isArray, and it'll tell you true or false whether or not that's an array. So to convert to a string, most things have a toString method that you can use on them. So you can do 5.toString. Maybe not. What have I done wrong here? Invalid syntax or unexpected token. Okay, so number is equal to, well, not number, sorry. Num is equal to 5. And if we do our console.log num.toString. So again, JavaScript syntax doesn't seem to allow me to do the 5.toString. Different languages can. I guess that might be an advanced feature of a language. But if you assign it to a variable, you can. What you can also do, though, is if you were to do 5 plus an empty string, that would convert your number to a string as well. Why you'd want to do that, I'm not sure. Like, obviously, if you're putting a number within a string, that's fine. But just in general, why you'd want to make 5 into it, without it being in a longer string, I'm not sure. We can also do, a Boolean where, we can do is okay, yeah, toString. Maybe not. Oh, sorry, I have the wrong thing. So my case got the best of me there. So is okay.toString is there. And of course, then, we can always do the string templates where we say num is and we put in her is okay. Oops, sorry. Cool. We can get kind of funky as well when we're starting to convert strings into numbers, which is something you kind of end up doing a lot when maybe if you're taking data in from a file or something, and it's all in text and you need to convert it into numbers. JavaScript has these functions within the global scope, and we'll talk a lot about scope today, where we can parse an integer from a number. So if we do age is equal to that, and we do type of age is a number, so age is 2 there. So we can also use parse float as well. To parse the float out, but we don't really need to use that there because we don't have a decimal point, but you can use it. And if we do type of parse float 2, it's still a number, because if you remember, we discussed last week, we don't have different floating point numbers and integer types in JavaScript. So one thing to get used to as well is the whole idea of not a number. So if we do try to do a parse int on John is great, no one understands or accepts that, and it's not a number, so and you can see JavaScript is crazy in that not a number is not equal to not a number. I don't know if that's a good thing or a bad thing, but that can cause some horrendous bugs from time to time. Another thing that you should note is if you do a parse int and give it, say, 1.1, it gives us number 1 back. But if we were to do 1.9, what's it going to give us back? 1. So good luck to you. So you have to be really careful with your parse int because it doesn't round. Whereas, if you were to do a parse float, 1.9, it'll give us a 1.9. Like what you could do is math.round parse float 1.9. So you could make a case that maybe you should never be using parse int at all. Because that's just scary. Okay, so that's how to parse a number from a string. And if you try to parse a string that's not a number, it won't throw an error. It'll just give you back this strange value of not a number. Did we do a typeof on man actually? So welcome to the Matrix, or Alice in Wonderland, or whichever. Because type of not a number is a number. Go team, go JavaScript. Love this. So anyway, I'll let that settle in and I'll move on. So let me just clear my console. So you can also use the number constructor. So if we were going to say const2 is equal to number 2, TWO, like you don't need to do that, but it is a traditional way of using the object to initialize itself. You can write a number literal the way we've always been doing, where it would just be const3 is equal to 3, and that's fine. But what you can do as well is const4 is equal to number 4.8, and what's the value of 4 is now 4.8. And again, you could also do const5 is equal to number 5 like this, and that won't throw an error. But what is 5? It's not a number. But then if you're like, well, maybe if I just check the type of 5, maybe it is a number. So yeah, good times. So that's just using the number constructor, and I'm kind of just illustrating how you can get some really crazy bugs when you're beginning JavaScript if you don't understand this stuff. For now, feel free to laugh at it, and in a couple of years' time, you will be crying at it at 4 o'clock in the morning when your software production system has gone down because of something like this. So we, I mean, you can do something like 2 plus 2 is 22. But if you were to do something like that, it makes the number 2. I never understand why. I just don't get it. It's a strange bit of syntax, but you can do that. If like I don't even know why you would do it. Madness is equal to. Does this even work? I don't even know. Yeah. Yeah, I would not let that code through a code review. No. No. So that's a bit of craziness with numbers and strings and converting. Good to kind of try out in the console, maybe the same way I'm doing when you're doing this. It's kind of a nice way to just play around and learn this kind of stuff. can just clear the console, Control L, and just clear the history as well. So the next thing we're just going to look at is some Boolean logic. So you very likely would have seen this working with Java already. So we want to write conditional logic using Boolean. So we're going to also look at all the falsy values in JavaScript. It's one of the things I look at when I'm starting a new language as well, not starting to learn a new language, is what actually equates to false in the language. We're going to use some if else, and we're going to have a look at the difference between double and triple equals. And yeah, so this is also good fun. So obviously an essential part of writing any program is being able to execute code that depends on certain conditions. So you want the navigation bar to look different based on whether or not someone's logged in, someone enters their password incorrectly, you want them to know, or just not log them in. You're building a game and you want to know whether it's X's or O's turn, and you're building a social network and want a person A to see person B profile unless they're friends. You don't want to, I guess. So we do this by introducing, the whole idea of Booleans and conditional ifs. And here's an example here where, we define a variable where Brenda is our instructor. And if our instructor is Brenda, we do a console.log yes. And if not, we do a console.log no. You should notice here, we're using triple equals instead of one equals. There is the possibility to use the double equals or the triple equals as well. And we'll show you some of that in a minute. But basically, long story short, when doing comparisons, always use the triple equals. So this is essentially saying if the instructor is equal to Brenda, it will return true or false. And, that can be if we do something like we can write it just as an expression here. Instructor is equal to great. I think the double quotes is the same here. The double equals, but the triple equals just always use. It's to do with different versions of equality. We'll discuss that in a moment. But you can then say, constant is Brenda is equal to instructor is equal to Brenda. So what we have here, oops, sorry, and is Brenda is true. So this whole section here is an expression that is resolving to a Boolean, and here it is resolving to true or false. So we can take that expression and we can do, well, we can take the value first of all, and do something like console.log Brenda. Or we can write the expression straight into the if statement, which is sometimes better. Whoops, sorry. So yeah, so maybe if we were to change that then to a lowercase b, what should happen here? Nothing happens. Our code doesn't run. Well, our code does run, but our console.log does not run. So we can make that a bit better by saying, whoops. I'll just clear that out. And we'll do an else. Console.log intruder alert. So yeah. Okay. So that's how we would compare essentially two different strings in this case. Um, we could also, in theory, ask a user, let me get my arrow back. What is your favorite food? Prompt them to ask that. And then depending on what the user has entered, we can perform some different operations essentially. So I guess in the previous example, this was always going to be true because Brenda is hard coded here. Whereas here we don't know what the user is going to enter, so we have to handle each case. If their favorite pizza, we want to be best friends. If not, we'll be like, oh, okay, nobody's perfect. That kind of thing. So, so yeah. So the difference between using 2 equals and 3, they're two different operators for comparison. So both operators check whether the two things being compared had the same value, but there's one important difference. The double equals sign allows for type coercion, and triple does not. So we look at what type conversion is now. But just so you can see, well, before we jump in, if we have a look at our console here, so we would be like, okay, well, 2 is equal to 2. Great. But is 2 equal to the string 2? No, it's not. But if we do 2 is equal to the string 2, it is. Because what has happened is JavaScript has coerced this string into a number. That might sound useful. Believe me, it's not. Okay, so let's just jump into coercion anyway. So, type coercion. So we want to add a number in a string. So in other programming language, this would throw an error. Sometimes, I mean, with the concatenation, maybe not. But JavaScript's more accommodating, so it evaluates the expression high by first coercing 5 into a string. So it's actually, making 5 a string here. So it's automatically converting 5 to a string and coercing it into a string and, kind of concatenating it to the word high here. So it combines the string 5 with the string high. And, that might not be what you want to do when you're in a case where you have, let's say, if we say const first is equal to 2, second is equal to 2, and then if we were to do result is equal to first plus second. I actually don't know what that'll give us now. I think it will give us 22 as a string. But in JavaScript, all bets are off. Just why you have to be really careful with this stuff. So I would have bet it was going to be 22, but I wasn't 100% confident. Because, we've seen different types of coercion, and we'll see more now. So you can see if you play hard and fast with different coercion, you end up in a strange place where you now have 22 in the result, and it's a string. But then, if you were to do something like plus result, it's now a number. So very confusing. So you just try and avoid all these. And how you avoid a lot of this stuff is to use the 3 equals. So, oops, sorry. My screen is gone bits, but we'll continue on. So JavaScript expects the values inside, the parentheses that come after the keyword, if to be Booleans. So, if you pass in a value which is not a Boolean, JavaScript will coerce the value to a Boolean according to the rules of truthy or falsy. Now, this can be a good thing, and this can be a bad thing, which is why I like to understand what is falsy. So if you were to do an if and just pass in a string, you get a, that will coerce into true, and you will get this console.log. Whereas, if you put a null into the expression here for the if statement, it'll kind of be coerced to a false, and this won't show up. So that's kind of falsy values. And we'll learn more of those along the way. And then the type coercion two, or number 3, sorry, which we just kind of went through a little bit, is, a common way to coerce a stringified number back into a number, is by putting the plus in front. And again, that's something I would not want to see in code, but it is possible to do. So in real life, you don't want to rely on coercion. We typically only need to parse a number from a string, say on user input, or maybe taking something in from a file. Parse int or float or actual data types. We want to do that as soon as possible in your program. And you also probably want to validate that a variable is the type you expect when you're taking in values, say from a user or from a file or from a web service or an API. The best thing to remember is, you should never have numbers as strings in your program. If you do, convert them as quickly as possible and validate that they are actually numbers. And typically what you can do is get a third-party validation library to do that, because, as we saw, we could do something like this. Const number is equal to 2. Well, actually, what we would want to do, well, actually, let's say we're expecting an int to come from a file, and, we actually get a word in there instead. Oh, sorry. I already have a number defined, and now I've got brain freeze. Let's just call it number of errors is equal to word. I'm going to parse int there. And then, if we did type of number of errors, we're still getting number. Whereas if we remember, number of errors in this case will be not a number. So you might think, oh, I'm doing something really nice here, where I'm saying, well, I'm trying to pull out a number of errors out of a file or something, and I'm just making sure it's a number here, and it is. But it turns out it's not a number. And this is one of the really strange things about JavaScript, but there's plenty of third-party libraries out there to help you validate that what you get from into number of errors is actually what you expect it to be. They do some more work in the background to figure that out, and they're tested, kind of in the open source community. Yeah, so you don't have to worry about them kind of doing crazy things. Mostly, you should still write your own tests. And the thing is also is just never use, like, there's rarely a rule in programming that you can say is kind of yes or no, on or off kind of thing. This is one of them, which is great because everything is usually in a gray area in some way, but this is not. Never use double equals ever in your JavaScript code. Ever, 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 never, ever. Always use the 3 equals. And it's so nice to be able to have a rule that can that you can rely on in programming, because a lot of them, as I said, are kind of, well, you do this, but sometimes, but in this case, no. Always use the triple equals. So, because there's just no coercion, just never use it. So we do have comparison operators in JavaScript as well. Forget about this one. Equal value and equal type. not equal, not equal value equal type. Again, just use this one. You should never really use this one. And then we have the usual greater than, less than, greater than, equal to, less than or equal to, and also the ternary operator. So if we were to think of falsy values, so some values aside from false are false as well. When they're used in the context where JavaScript expects a Boolean, we use or JavaScript will use coercion to make them a Boolean. So even if they did not have a value of false, they can be coerced to false, in a Boolean expression. So that's not right there. But if you were to do something like if 0 console.log 0 is, oh, sorry, 0 is true, else console.log is false. So there we go. And I'm going to get rid of that 0 there because I can use this example over and over again. We can say an empty string. What would that be? Is false. Then you kind of ask yourself, well, is a bit of white space true or false? It's true. So, you can see an empty string is, but a space in there, resolves as true because the string is not empty. Typically, what you do to avoid things like that is you'll stick a trim in there and it removes any trailing white space. Anyway, you'll get to that later. Another thing, a lot of the times in a lot of languages, empty arrays are false. Let's see what it is in JavaScript. Is actually true. So what you could do, is array.length, and that would be false because the length of the array is 0. My favorite part of JavaScript, which we, not a number, is false. Undefined is false. Obviously, false is false. The string false is true because that's not coerced. So again, you kind of see you have to be very clear with your types. So when you see falsy values, what that typically means is what in the language will evaluate to false. Okay. So, we also have an if else. So, sometimes you have to more than 2 conditions to check. And so we can chain multiple of them together. So, we've if a number is greater than or equal to 1,000, we want to do, a console.log. Else if the number is greater or equal to 100 or 0, we do another number and then else. So you're just chaining if, else, if, and then else's at the end. So the else is always run. You don't need to have an else. And if neither of the conditions are true, neither of the statements are run, and that's fine as well, depending on your use case, really. So this should be familiar to JavaScript. They both derive from kind of the C syntax, well, C inspired syntax, I would say. So you should be familiar to Java, JavaScript, that kind of thing. We also have a switch statement where you can switch on a value up here. And this can be a nice way to write things as well, depending on what you're trying to achieve. So for each case, we run arbitrary code, and this can be multiple lines of code. And then we want to break out of the switch statement. So we're done. If we didn't have the break here, we'd go and keep evaluating. And if we matched any of the ones down below, we would run those as well. So that can be a cause of a lot of bugs. And sometimes that can be desired behavior, but typically if you're doing that, that's again a kind of an indication that your code is bad and it's going to confuse people because it's not something you intentionally do a lot. So you might want to use a different construct. And we have a default down here then if none of these matches, like the else of the switch, is we just do our default down here. One is the modulus operator, is where, it basically divides a number by another and then tells you the remainder. So if we were to look over at our console over here, which is not working for some reason. Okay. Control L, perfect. So if we do 2 modulus 2 is 0 because 2 divided by 2 doesn't leave a remainder. So if we were to do 2 modulus 3, the remainder is 2. Whereas if we were to do, as in our example, well, the previous example is confusing because, yeah, it's bigger, but you see 5 modulus 3 and is 2. And this is a good way of checking if something is an even number. So I guess we have the example here already without me looking at the notes, without me writing it down. But basically, if the number modulus 2 is 0, so there's no remainder, the variable is even, else it's odd. And I guess else if, and then, if we didn't give it a whole number, it could bleed into our else. So what if we were to do something like 2.2 modulus 2? We have a nice rounding at the end there. It's pretty nice. But yeah. The modulus operator is one that's asked in a lot of interviews as well. And you can come up, actually, you end up using it a lot more than you would think. So if we're thinking about different data types, we have, well, we want to introduce the idea of object data types. So if, we're thinking about what we've been looking at already, we've kind of been looking at primitive data types, such as numbers, strings, and Booleans. Whereas if we start looking at object types, they can hold more than one value. So, a number and a string, 2 numbers, 3 strings, and 2 numbers. And we'll just investigate here now and introduce the object data type in JavaScript. So to create an object, we use curly braces, and then we have key values. So here we have Homer with a first name Homer and a last name Simpson. So let's just do that here. Excuse me. Obviously, I made a mistake there. So here I've kind of written it on one line, but you can see it's quite a bit nicer to write it kind of on 2 lines here. So that's generally how it's done. I just wanted to show you that it can be done in a different way. You can write it in 1 line if you like. But generally, kind of depends. You typically have in a development shop or company, you have a max line width that you work to, and your linter will fix it for you. And we can access Homer.firstName just like that. We can do Homer.lastName just like that. Sorry. We can also access it via this syntax here, which might seem a bit strange. And again, we can do the same with last name. For now, I think it's good to just focus on the dot notation. You will use the accessor kind of notation when you do kind of more complex programs. It does exist, so if you do see it, that's kind of what happens. In some languages, this even works. I don't know if it works in JavaScript. No, but that can work in some languages as well, I think. I'm pretty sure I'm not making that up. So we can also have, you know, throw an age in there as well. So they don't, all the properties within the object don't need to be the same type. And if we were to do a console.log of, say, Homer, we can see, the object renders quite well in the console. Also, if we just type Homer, it's kind of the same thing. I don't like the way console.log does the first one in the JavaScript console, because that's not how it works when you're working in a program. So it's trying to be helpful here, but I don't really think it is helpful. I guess if I was to do like to string, yeah, I guess that's different. But really, when you're working in something like Node.js, when you do a console.log of an object here, you will just get the object rather than the runtime kind of giving you a nice way to work with the object here. I guess this is nice for the console, but I think it sets unrealistic expectations. And what we can do is go homer.age equals 36. And then if we were to just have a look at Homer again, we can see that we now have an age. And you might ask, what is this prototype here? And I'm not going to answer that right now. That would just melt us all. But basically, JavaScript is a prototype-based language, but let's not worry about that for now. So if we were to look at the object, we have the name of the object here, which is Homer, which is the name of the variable, essentially. We have attributes within our object, which I think I was calling properties there a minute ago. The joys of doing live. But we can see, we have our key value pairs, the way I like to call them as well. But our attributes, our fields have first name, last name, and the values of those are Homer Simpson. Yeah. So hopefully that makes sense. It's a literal way of writing objects. It's quite nice. As we've just shown, objects in the console as well, make it easier for you to inspect objects and maybe play around with them a small bit. It is possible as well to add methods to our objects, where we may have first name, last name, age, and then we can give it a method of say hello. So if I was to do it a different way, I could say Homer dot say hello is equal to, I don't think I can use an arrow function here, but let's give it a go. It's not that log. Hi, Homer. We do Homer dot say hello. All right, it does work. So if now I was to just do Homer in the console, you can see here that I now have say hello in there as a function, which operates as a method. I think the specifics of using an arrow function for that are kind of incorrect, but let's not worry about that for now. We'll get the functions later. But for now, you can write them like it is on the left-hand side here. But yeah. So yeah, just kind of deep diving a bit more into that, like we did on the right-hand side there. We can call the method then with just the dot syntax, and we could in theory, pass stuff into that method as well. So I guess we also want to introduce the idea of this. Where my arrow is pointing in the wrong place. But it is possible to reference within the method here the different parameter or the different attributes of this object by using this. So that's kind of similar to the likes of JavaScript. And if we take a look at the response down here, we can see we're referencing first name inside that object. Sorry, similar to Java when you use the word this property. Okay, so that's everything on working with arrays. Working, I guess, with conditionals and an introduction to arrays and things like that. So, well, an introduction to objects. Sorry, it'd be great if I could speak. So what we're going to look at now is just let's have a look at arrays. So I'll just make this full screen. So I guess, when we're talking about arrays, we're talking about multiple values within a singular data type, but via an index. So, I guess variables are fine if you know how many, in this case, prime numbers we will need at the outset. But what if you didn't know how many values you needed to store? I guess it's a good way of thinking of it. Go full screen here. So what we could do in that case is introduce the whole idea of an array where we have 1, 2, 3, 4, 5 prime numbers in an array there. We have 3 names in an array. We have, a number of Booleans. We can also mix our types in an array, which is, in standard Java, you don't really do. And we can also put arrays within arrays. So you can see this is just a string, whereas this is an array within an array. So to write an array in JavaScript, we just use our curly braces. So, we can do something like numbers is equal to 0, 1, 2, 3, 4. And if we want to type numbers here, you can see it's an array with 5 elements in it. And we can do different things on it. Array.length. Numbers.length is 5, that kind of thing. So that's our array. So we define array really just by just doing square brackets like that. We can then, add to the array using the index accessing notation. So we can do array0 equals hello. Array my array1. Let me just do this is equal to there. And then if we have a look at my array, hello there. Yeah. So to, I guess, to access an element of the array as well. So we have my array. We access via the index, and the index is start at 0. Up until a couple of years ago, every language I ever worked with would start with 0. Lua is the language I started teaching last year, the year before. It uses 1 as the base index. So we use 0 to access the first element of the array here, and we use 1 to access the second element of the array. So it's 0 indexed. So you'll just get used to that. And unless you venture into some other languages which are a bit more obscure, generally arrays are always 0 indexed. So just make sure I'm not missing anything here. Oh yeah. So one thing you can do as well, some languages allow you to do something like my array -1 to access the last array, but JavaScript doesn't let you do that. Or sorry, to access the last item in the array, but JavaScript doesn't let you do that. But typically, you can do something like my array.length -1, and that will give you the last element of the array. If you try and access something that's outside of the array, such as my array2, you just get an undefined. And in Java, you would get an array out of bounds exception if you try to do that. So we can also do something like my array 5 is equal to like that. And then if we go, well, my array now has 3 empty spaces in there, essentially. So you don't have to have the array full. We now have 3 empty spaces in there. I'll get my arrow back. Here we go. So, but what is our array.length? So our array.length is 6. So we have, I guess, 6 items in there, and 3 of them in the middle are empty. So console.log array, sorry, my array even, to string. So that's typically how you'll end up seeing it in a JavaScript program if you end up having like empties in there. And obviously, if you're iterating over this array and you're trying to do something with the empty, it's going to throw, an error. So, if we were to do something like my array.for each, and you would not have seen this before, so don't worry. Console.log it.length. Well, let's just console.log it first, make sure I'm not doing anything wrong here. I was expecting that to throw an error, but it doesn't. JavaScript surprises me every day. That's new to me. Anyway, okay. But it just goes to show, like, generally, you don't intentionally want this. So generally, you don't see a problem here. But what I was expecting there is it would go hello there and then throw an error for me. But it didn't. All right, cool. So yeah, so we've gone through accessing elements in an array. You can as well, I guess, update elements in an array where we say array 0 is equal to hello, maybe with our uppercase. And you can see we have now our uppercase there. And yeah, as we can add to an array as we did up here. Well, where are we? We did here, where we have our my array 5 is equal to Kenobi there. So yeah, you can add in any index and you get the undefined, and that kind of thing. If you want to add to the end of an array, you can push items onto an array as well. So if I was to, another array is equal to 1, 2, 3, 4, 5, I can do another dot push and put 6 on there. And we can see 2, 3, 4, 5, 6. And you can also do another dot pop, which will give us 6. And that actually changes the array itself and pops off the number 6, but it gives you back the value it pops off as well, which can be useful, but also confusing, that kind of things. But push and pop can be useful to mimic the idea of a stack. You can add to the beginning of an array. You can use unshift. As we push, it returns the length of the modified array. So if we do another dot unshift and give it a 0, we can now have a look at that array, and we put 0 at the front of it. It's a strange name, but you can shift an array around as well. I guess to remove from an array, you can just change the length of it, which can be a bit strange, where we're just like, another that length. At the moment is 6, so but if we were to set that equal to 4, the other values just drop off the end of it. Typically not something you would do, but so yeah, as mentioned, we can pop off an array as well, like that. And you can also shift an array along as well, where so we have 0, 1, 2, 3 here, and if we do another dot shoot, sorry, we've removed an element from the front of the array here at this point. Is the opposite to pop. I'm getting ahead of myself. So we can use shift to shift an array along, and you can give shift a number as well, so that it moves up the index, and that's kind of confusing as well. So we can do that again. You start getting quite confused by, the different numbers as indexes and different numbers as values here. So it can get a bit confusing. But worth looking up the API documentation as well. So you can also use the delete keyword to replace a value at an index. So it's a bit strange. So if we make an array is equal to A, B, C, and we just take a look at that array, we can do delete array 1. And now we take a look at that array again. Oops, sorry. You can see we have A, an empty space, and then C in there. So that's kind of the basics of arrays. You rarely do a delete. You would end up doing like the likes of pop and stuff a lot. Knowing methods like shift and unshift and things like that can be quite useful for things like interviews, stuff like that. They kind of like to ask those. So that's kind of basics of arrays, and now we want to look at just arrays of objects. So this can get a little bit confusing visually, but just to introduce it, and you'll work with it in the lab as well. So let's just move to full screen here. So if we think about the arrays we've been looking at, so we put numbers and we put some strings in there. We have an array of a song list here, which is just strings. And, we can see that we just have strings in there. we can iterate over using a classic style for loop, and print out the index, what is song 0, what is song 1, and what is song 2. So we can get a bit funkier with our for loop as well, where we have a 0, 1, 2, 3, 4, 5. Where we would say, oh, 0 is the name of the song and 1 is the composer. In this case, we have it called artist. And this would be some logic, you would build into your code and hope that everyone understands. But of course, this is terrible. You don't want to do this. Like, what you would typically want to do is an array of objects. So if we take the previous example where we're just like, oh, essentially all the even, including 0, are the song names, and the odd are the artist names. That's just that's not cool. Don't do that. We open an array here, and then we have a number of objects in our array. So that syntax can get a little bit confusing at first, but you can see it's a lot easier to read and deal with and work with in your code. So yeah, so we have a single object there, and each object has a title and an artist. And so then, as you're iterating over them, you start doing more object-oriented things like, um, you know, pulling out the song and using the title and using the artist, and it's becoming more readable, less cognitive load to figure out what's going on here, and that's kind of the important thing, less complexity. Yeah. So here's an array of objects that is more complicated, where we have an ID, a title, and then an array within our object of songs. So you can see here, this is an array within our object. So just zooming in on that a bit, because it was quite small, we can see just here we have our ID defined, say as number 1. We have our title, and that's the album title. I don't know, do you call it Beethoven's albums, or I don't know, whatever. And then we have our songs, which is an array of objects with each of them have the same properties or attributes or field names within them. So, if you were to do a console.log of that, in the console I'm using now, it actually is behaving a bit different because these notes are a little bit older. You'd get, object, object, object. So that can be a bit confusing, and that's what you get if you're running, in Node.js. So you're running your JavaScript maybe in a different browser. So let's just try that. So let's just do const objects is equal to name, John, age 27, then name, Joan, age 28. And so if we do a console.log of objects, it actually breaks out the object for us here, and this is newer behavior in the console than is described here. But if you're running an application and you try and do a console.log, you'll just get this, so it can be a bit confusing. But what you can do, I guess, then is iterate over them, and basically print out the individuals, and back right now it's not actually a problem, but back the notes are a couple of years old, so that's what the Chrome console used to do. And I'm using Chromium, so your Chrome console might actually still do that. I'm not too sure. So yeah, so then, here's just an example of iterating over the playlist using a classical for loop. And, for each, just printing out the title using console.log. And then we have an embedded for loop here, which is horrendous looking. Kind of melts your eyes a small bit. But basically, what we're doing is iterating over the array of objects, and then within each object, iterating over the songs. You can see here we have, the album name and then all the songs, and the same as we move down. So just different ways of iterating over. You don't really do it this way anymore. And we'll get into more functional style approaches as we move through the course. So that's just an introduction to arrays of objects as well. So there's been a lot, I guess, here, but there's a smallish lab to go through the basics. If you've been following along a lot, we've been doing a lot, so you might not even need to do that. But give the lab a go, especially if you're new to arrays, or even not. Even if you've used them before, it's good to kind of just practice. So we're coming up on over an hour and 15 minutes. So I took my time with that just to kind of give you an idea of me and how maybe you should have a console open or somewhere to write JavaScript when you're learning these things, to just try and figure out different things. I had no intention of ranting about not a number being a number, but these things come back to me as I'm doing things as well. So I don't know whether that was good or bad, but anyway. So the last thing I want to go through, so we've kind of talked about how we would use JavaScript arrays, how we would use objects, how we would use if statements, and just introducing you to the language. But what we want to look at next is how we get JavaScript to run in the browser and how we run scripts on web pages. So right now we've just been running them in the console or in our Sublime Text, or if even, I don't even know if we have been. I think we've just been staying in the console. But now I want to introduce the idea of putting a script on our web page. So let's go full page on this. Cool. And this is achieved via script tags. So script elements. So the script HTML element is used to embed, executable code. You can also use it to embed data. Typically used, JavaScript code. We want to embed JavaScript code into our web pages. You can also use other languages such as WebGL and things like that. But typically, well, we are just going to be using JavaScript. We're not going to be doing that crazy here. So when we're using the script tag, it is possible to run JavaScript just in our page as inline JavaScript. So right now here, we're just running hello world here. So we can basically just put JavaScript right in our HTML file. So if we remember our labs, and honestly, if you're not doing the labs, you're going to start getting very lost. So you really should. In our labs, we've done this without kind of talking about it too much. We've just introduced certain things where, we have our script and we have some JavaScript in there to get our hamburger menu to work in our Dotify app. So that's an example of an inline script in our HTML. And you can see if you have more than this, your HTML file is going to get messy and really large and kind of hard to maintain. So inline scripts run in the order the tag is placed on the page. So if you have a script in the head, that will run first before the body is loaded. If you have a script in the body tag, it will run at the start of the body, and all the stuff will happen in the middle. And then if you have a script at the bottom of the body tag, or just, sorry, at the bottom of the body just before the closing tag, they'll each run at different times. And that's important because your script might be running before the page is fully loaded. And that's kind of what's happening here. The page is going to run, the head is going to run before the page is loaded and rendered. And that will mean things later on in this lecture. So scripts that run in the same page are all executed in the same scope. So this can get a bit confusing, but scope is a term used to describe where the script is running, and what variables it can see and potentially kind of augment. This can cause kind of some confusion, but it doesn't make sense. But scripts are not executed in isolated environments. They're executed within the context of the page. So if we were to look at our head over here, we're defining a number as 1. And you can see we actually have access to that number then in the individual script tags further down the page. That might be a surprise because you might think, oh, each of these little scripts is self-contained. I think you'll play around with that a bit in the lab as well. So when dealing with scope, within the scope of a web page, we have access to what we call window. And the window interface represents a window containing a DOM. And the document property points to the DOM document in that window. So you can see we also have the document, which we've already used. So the document interface, represents the web page loaded in the browser and serves as an entry point into the web page's content, which is the DOM tree. So the window is typically talked about as the global scope, and our global variables exist there. It's generally bad to rely on that, so you shouldn't really rely on it. But we've used window, we use document. And if you were to do window.document, it's kind of the same as doing document. They're the same thing. There's just a shortcut variable added to the global scope for document, so you don't have to type window all the time. So you can see here we have our window, we have our document, and both of them, window.document is equal to the document. So with things like the window, we can do, what's the width, what's the height, and what's our current location. So here's our width, here's our height, and then our current location is we're sitting at localhost. So what is then console.log? So console.log, the static method, outputs a message to the console. The message may be a single string. We can do substitutions in there, or it may be one or more JavaScript objects. The console provides access to the console object provides access to the debugging console as well. The specifics of how console.log runs vary from browser to browser and server runtimes, but typically there is a kind of a de facto standard. And if you go look at the documentation linked there, again on MDN, it can be quite educational to review that. And again, mentioning console.log because that is in the global scope as well. You can just use it everywhere. So we can also add in our script element, rather than just putting code in here, we can set the source attribute to a JavaScript file. So this allows you to separate your JavaScript from your HTML. And that's almost like separating your style, your CSS from your HTML as well. Separation of concerns is likely a very good idea here. So we can move our code from having this script here and all this complexity in here to what we have over on the right hand side here, where we'll just have a source set on our script tag to say look in JS/Bulma. So scripts run this way also share the same scope, so that can get a bit confusing. You're like, how does this script know about that script? The document variable is also available to you in those scripts, even though you feel like you're running them externally. I mean, the sharing the scope can be convenient, but it can also introduce a lot of bugs, so kind of be careful there. So this, you kind of might have noticed that the scripts we were running, the JavaScript, sorry, we were running in the previous lab was inside something called an event listener, listening for the DOM content and loaded event. We haven't really covered this yet. However, this event, is useful to use to wait for the entire page to load before we start running JavaScript on it. So then we can manipulate the page after it is fully loaded. This can be very useful to populate dynamic values, and you'll do this in the lab today. So in the lab, we're going to write some scripts to wait until the page is loaded, and then select different elements and set data on them dynamically. So as you can see here, we now have, just for our chill, we've set the values dynamically here, and in the lab, we'll fix these ones as well. So as we move into our Dotify lab, you can download the source from the last time, get it up and running. We'll start working with the script tag to move the script we have into the Dotify, into a separate JavaScript file. But the first thing, we will do is just investigate running different scripts in the head, in the body. We'll augment the DOM. We will get an error because we're going to run it without being loaded. And I'll step you through setting breakpoints in your code in the console. If I was to do that now, we'd be here for another half an hour. So I doubt you want that. But I'll probably step through this lab anyway in a separate video, just because there's quite a bit going on here. And we'll get to a point where we'll start adding values to the page using JavaScript, and then some exercises to work with, as we've seen, an array of objects to populate the rest of our playlists here. So that's everything for today. That was quite a bit. So best of luck, and I'll see you on the lab video for this one, which I'll get going soon enough. Thank you.